Hey everybody, we're here for another Tech Talk with Paul and Al. And today we're going to fix a stereo. Isn't that right, Paul?
That's right.
So what kind of stereo are we fixing?
We have a classic Pioneer SX1500. And I meant to go pull a schematic on this before you got back, and I fixed myself a fried egg sandwich instead.
Well, who could resist that?
Well, I couldn't. This one has intermittent FM. Everything else works. And the weird thing is, when you turn it on, you'll have FM for a second or two, and then it disappears.
And so there's not even a stereo problem, it's just no FM.
It's FM. AM works. And the funny thing is, right now we have no FM at all, but I've got signal strength meter and tuning meter
that say it's there.
The tuner is working, so we know it's not the front end, it's not the IF, it's not the power supply. And I'm assuming AM works, aux works, even FM mono's out, so it's not the multiplex.
Would it be the FM detector, or is that already...
No. I'm already a little bit ahead of you. That's what the scope's out for. I have audio up to right there coming off the end of the IF.
So that's the output of the FM detector?
That's the end of the IF strip. That's audio.
And you can see very clearly it's tuning. You're tuning it now.
Yeah.
You see a little DC change, but...
Yeah, I got a lot of noise in there too, but it's picking up noise off this monitor.
Well, probably didn't have a good antenna, really.
Well, no. But I've got audio there. That's the easy part.
So this is all about, troubleshooting and signal flow. You always want to follow the flow of the signal.
Where are we losing it? Well, I checked B+, front of the IF, front of this IF, the front end, and you can touch the audio output on the multiplex board. It hums, so we know we've got output.
The output from there is good.
Right.
So it's somewhere between the output of that IF and the into the multiplex board.
Well, here's the kicker. I've got audio there, and there's a small inductor. I've got audio here, but this is the input to the multiplex board. I don't know what this board does yet exactly. But I can bypass this board, and I've got FM.
So that means that something's wrong with that board, on that board.
My guess is it's bad capacitors. They're happening a lot lately.
What's the function of that board?
I don't
amplifier?
know. I was going to go pull the schematic and see.
Uh-huh.
I'm sure it has a function, probably muting. But
oh, it's to get rid of the noise between the...
It's probably, between
stations. You have an unmute button, a mute button on here?
It does. It doesn't do any good. Let me see. Muting right there.
Miranda deal with their lives in the top.
Nope.
Yeah. So that might be your mute board to get rid of all the hiss between channels.
Yeah, could be. So that's where we are.
And it doesn't really seem to have much amplification because the signal's good coming. And you've got stereo?
Don't know. Don't really care at this point.
Well, let's go
I've only got one speaker connected, so it really doesn't matter.
Yeah.
What I need to do is go get the schematic, find out what that little board does.
Well, is the stereo pilot kicking on and off? There's a pilot indicator.
Well, there's a light lit up here, and I don't know if that's a stereo pilot
it's still
or not.
lit up.
Yeah, it's that stereo pilot. It's hard to tell. May just be a pilot light, but anyway, I need to go get the schematic and see what I'm dealing with here. But that's where
you've done some really good troubleshooting, and just while you're going to get your schematic, I'm just going to talk about...
Yeah, you could have been watching while I was doing this other diagnostics, but you was busy eating, and so was I.
So, basically, you have your tuner section.
Yeah, this is a neat... This is old school receiver.
It's a
you have an FM front end, an AM front end, tuning condenser, FM tuners under here, AM IF, AM audio outputs right there. They turn the B+ off when it's not in AM.
This is basically a superhead.
Yeah, it's two superheads.
An FM superhet and an AM superhet.
Exactly. And then you've got an FM IF. It comes off right there off this tuner.
Uh-huh.
So you've got mono FM, mono AM, whatever the heck that is.
But you've got wideband mono, so you can do the stereo demodulation.
Well, yeah. And then we've got a stereo decoder board, and whatever this little bugger is, and then your power amp
Yeah.
and your preamps are buried across the front here.
Yeah.
This was sometime in the 70s. I've worked on these when these suckers were new.
Mm-hmm.
Takes me back. Weighs a ton, has a big transformer, sounds good, probably has metal output transistors.
Well, see, the thing is that lets people understand Armstrong invented the superhet.
Yeah.
And he also invented FM, even though he didn't get credit for it until later, after he committed suicide.
Armstrong and Sarnoff fought over that for years.
Yeah, and then he committed suicide.
Because Armstrong and Sarnoff kept throwing him out.
Yeah.
And trying to break his patents. Armpro was a genius. Sarnoff was just evil. A good corporate tycoon. Yeah, he wasn't very nice. We won't go any further with that, but David Sarnoff was not a nice man.
Yeah.
But
well, he said he enjoyed
successful.
aggravating people.
He was good at it.
Yeah.
So anyway, this is a nice receiver made in the 70s. And you talk to yourself. I'm going to go pull up a schematic on it.
Well, hey, the thing about this is, I'm talking,
What is it?
about the circuitry here.
Yeah, you do
Is that when in a super heterodyne receiver, what's going on is you have multiple frequencies coming in on the tuner section. As you're adjusting this capacitor, you're actually adjusting band pass of the received signal coming in from the antenna, which that's the antenna line. And then also you're adjusting that, and it's actually being super heterodyne against an oscillator. And the thing about when you do that, you take the incoming signal and you super heterodyne it against an oscillation signal, and the resultant is four things. You get the two fundamentals that came in, which was the tuned frequency and then the oscillator frequency, and then you have an output, which is the addition of those and then the subtraction of those. And the subtraction frequency, which is always set by changing the frequency of the oscillator, is going to the IF. And so the intermediate frequency amplifier section is this right here. And what that's doing is that is allowing multi-stages of amplification for the signal. Now it's still modulated signal, but it's at the intermediate frequency instead of the tuned frequency. And so you don't have to have a lot of amplification that's wide band. You just have it at the intermediate frequency. And then at the very end of this, you have an FM detector. An FM detector basically will take a shift in frequency and turn it into a shift in amplitude. And that produces audio from an FM signal. And then what we've got going on here is we have I guess a muting circuit. We're going to look at the schematic and find out if this thing right here is a muting circuit to get rid of the hiss. And then over here, what we have is a multiplex detector. And what that does is multiplex takes the FM signal and it produces stereo from it. And what they do when they broadcast FM to make it compatible with monophonic FM is you have a lower frequency of FM in the audio range that is left plus right. It's a sum of the two channels. And then you have another signal sent at a higher frequency above 19 kilohertz that is, I think it's around 38 kilohertz carrier in the audio range that is left minus right. And so, and there's a pilot signal at 19 kilohertz. And when this sees the 19 kilohertz pilot signal, then what it does is it knows that you've got a stereo signal, and so it processes it. The way it processes it is by taking the left plus right and adding it to the left minus right. And so you have L plus R and L minus R, and so the two R's will cancel and you just have left coming out. And then you take and you invert the L plus R and you have you invert it and you have a minus L plus R, and then when you add that together, you get your right channel. And so that's how they separate the channels of right and left and still allow it to work with monophonic compatible receivers. And so that's a pretty interesting thing how they did that. And it's all just with the addition and subtraction of audio signals. Even though the 38 kilohertz carrier for FM L-R is above your hearing range, it is on a carrier, and so once that's detected, and it's an AM carrier, by the way, once that's detected, then you can you have the audio again, the L-R audio. And so this is the way they came up with mono-compatible FM stereo. And of course, FM used to be at lower frequencies when Armstrong had his own FM signals that were broadcast at lower frequencies and were not, line of sight signals, and so consequently the early FM could go, more than halfway across the country. But then Sarnoff lobbied Congress, had FM moved to the line of sight frequencies up into VHF, and that was the end of the Armstrong network and the beginning of the feud of Armstrong and David Sarnoff. And of course, David Sarnoff, the owner of RCA, was just a really good businessman, and he didn't particularly care about who invented it. He wanted to make money from it, and so with all the lawyers he had, he was able to block the patent on what Armstrong legitimately invented until he kept Armstrong in court for a year, and then Armstrong committed suicide. After his death, they finally awarded the patent to Armstrong's widow. I was telling everybody about how this worked, and I'm trying to remember what the IF frequency was for FM in this.
10.7?
10.7 megahertz. Yeah.
Yeah, typical FM IF.
So here's your drawing.
Yeah.
And so does it show what that circuit is?
Yeah, it's the muting unit.
It's the muting, so it's got 3 transistors.
Yeah, two capacitors. Input, output, this is where we've bypassed.
Uh-huh.
And muting voltage, it says DC in and switch, so I'm assuming that there's a voltage derived off the IF and there is a switch to control it.
So the voltage off the IF is an indicator of whether there's a station or not.
Right, and there's probably a threshold adjust right there.
Yeah.
And you kind of have to match the dots on this.
Well, you hear how it's popping in and out right now?
Yeah, it's trying.
Uh-huh.
So
well, maybe a threshold adjust would do it. I think it's probably cap.
No, because it comes on for a moment when it's cold and then it goes away.
Yeah,
so.
That says cap.
Let me see. DC in, AFC, output. Yeah, I don't have a frame drawing. I didn't print drawing. Yeah,
it's trying.
That's annoying. Where's the jumper?
Unfortunately, this is transistor, so it doesn't have ultra high voltages to shock you like a tube.
The birds are gone out of my backyard.
Now the power out's at 70 volts, but that's about as high as it goes. There's a coupling cap between the two.
Could it be that simple?
Well, I think it's a coupling cap. Let me see, from pin 2.
It has 3 stages, so it could be a coupling cap
pin
anywhere.
2, and there's a coupling cap on the board, but we jumper from. Oh, there's a coupling cap on the multiplex board.
Uh-huh.
That's an output 3 goes to multiplex 2.
Of course, we could take the oscilloscope and go stage to stage.
Well, we could, and we may have to here in a minute. And pin 2 on the little board, which is the one where the coil, that's a resistor actually between the IF and the muting board. So there's a coupling cap on this little muting board. Could be our culprit because it's right there.
Yeah,
Input.
Just to help our viewers, the coupling cap is there to pass the signal and block DC.
Yep.
Because you have to have DC bias on each transistor stage for it to work.
Which is how they mute it. They saturate that transistor to mute it.
Right, and so, but if you had DC coupling from stage to stage, it wouldn't allow you to properly bias the transistors.
Boy, would you have some bandwidth. had a receiver with some shorted coupling caps on the audio board. Boy, did it sound good. Lots of bass. Okay, that's the wrong capacitor.
Well, a capacitor will readily pass high frequencies and not so much low frequencies or DC. So a bigger cap will pass, and bigger as far as the value of the cap.
Yeah, lower frequencies.
So what you're doing is you're doing a bypass,
I'm trying to find the legs of that offending capacitor.
and you're using another capacitor, and you're just going to do a bypass.
Yeah. And we're not getting lucky.
Of course, this capacitor is so big
Yeah, but
that it'll pass a signal.
we hit something. I think there's a biasing issue with that mute circuit.
But it has a delay after you
And
disconnect.
it may be a leaky cap causing it. But if it's just an
Well,
open,
usually it's not a semiconductor or a resistor.
usually, but I think this one's being biased off. Because I should be able to just jumper.
Mhm.
As a student, you'll get a
And
personal
it could go
success
right
coach like
through.
me. Renee.
Yeah, and there's the coupling cap in question right there.
Uh-huh. And what is that? What
think.
size cap is that
Let me
you're
see.
using?
It's a 33 at 160.
And you're not really concerned about polarity
No.
there?
Well, I've got the negative end from the source. It really doesn't matter at this level.
Mm-hmm.
Let me see. Eyeball trace. There is the output right there.
Success story at Strayer.edu. Strayer
You did
University
something.
has 4
Well, that's
campuses
the
right
output.
here in the Dallas area.
So that's the same as
Success.
going here or going
Earning a
there.
bachelor's with classes on
Still think
campus
it's a
and
coupling
online
cap.
at
Well, that tells you the wiring
Strayer.edu.
between the boards is good.
Well, yeah, that's always good to know.
Music Awards. Okay, maybe not. Unless they win the King.
There was a good clue.
What did you find?
Well, I hit a B+ point with this cap and then discharged it between the ground and that output pin. And all of a sudden, it's cured,
Uh-huh.
which means I have healed a bad capacitor
And how did you do that?
by applying voltage in reverse across it.
Okay. Well, that's just a temporary healing.
That's just temporary, yeah. That's an old trick of the trade. And that could mean it's a cap on this board or this board. If I was smart, I'd get my ESR meter out and do this scientifically,
Yeah.
which is probably what I will do tomorrow.
So we'll call this part 1.
Yeah. I need to go print the board layout so I can identify exactly which capacitor I'm dealing with. Turn that down. Yeah, it's working right
Texting
now.
and FY.
That's what infuriates you. You never know where the problem is when it's working.
I hate intermittence.
Yeah.
Give me something dead anytime.
Yeah, and see, the problem is if you assumed
Yeah,
it's
see
fixed and
it-
you
see
took
it-
it back to the customer, it'd break down.
It's croaked again.
Department of Transportation.
Now, if you were to bypass that board entirely, you'd just have noise between the channels.
Yeah, you would have to mute them.
Late night happy hour. Like what?
Like that.
Yeah.
And ice cold draft beers and appetizers at only $2. That's
Yeah.
happy hour at On the Border Mexican
But
Grill.
that'd be a
and
cheap
Cantina.
fix if you didn't want to fix it
I
right.
wonder if we have DC getting past a capacitor from that IF board to. I need a hole to put that.
You mean a
ground wire.
DC leaky capacitor?
Yeah. Wouldn't that be funny?
So basically, it's not a capacitor.
Not much of one. Not so much.
It's not enough to really consider
No,
DC.
No, I wouldn't.
That's just within the normal range. Of,
Yeah. Wouldn't call that a leaky, but there's a bad cap, and it's there or there, and there could be bad caps everywhere.
well, you know, capacitors
But-
age. They're made out of fish oil.
Not well back then they may not have been, but they are now. But it's a bad cap. I'd bet money on it.
Well, they had that poisonous chemical they used for a while.
PCBs.
Yeah.
You want for left?
Well,
But it'd be a solder joint.
it could be a lost ground. I've rocked these boards.
We could all use a little or a little metaphorically speaking. Visit your local booth.
I would say it's a possibility of a bad connection.
And it'll look that way, isn't it?
And participating dealers and boostmobile.com.
That's what the soldering iron's for.
That's right. It's not even turned on right now. Well, I'm finding bad caps in a lot of these doing weird things.
So you need to really fix it right.
I got to find the actual problem.
Mhm.
But that definitely looks more and more like just a connection issue. Now I went in here and did this and pressed.
Yeah, but when you do actually the components on the board,
Well, looking for loose grounds.
yeah.
You know, think, oh, it's a loose ground. No, did this, nothing.
But when you touch the
And I
components,
did this, nothing. You get that one though. But that could be soldering, it could be a bad transistor.
Wait, yeah, reduce pollution. No.
well, these were flow soldered or were they hand
No,
soldered?
these were flow soldered.
Yeah.
So,
And even send you maintenance.
anyway, maybe that's all it is.
Well, we'll just see what happens in class
I'll resolder it, and if that doesn't do it, we'll go find a transistor.
2. Yeah.
But that's how we did it in the old days.
Mhm.
Back when things had components, we could actually fix circuitry.
Mhm.
Nowadays, throw it away.
Well, this is not a change the board unit. It is a.
No. Back then, you could buy these boards.
Uh-huh.
You fix what you had, or you did without. Boards were not considered a replacement part,
Yeah.
and we were taught to work at component level.
Uh-huh.
However far down you had to go, you found the bad component and you replaced it.
Well, you see, the thing is with this, you could also approach it by taking your oscilloscope and following the signal flow through the board.
Yeah.
But this what you're doing here is really give you an indicator, because when you're
Well,
adjusting the physical position of that capacitor,
Yeah.
it fixes the problem.
Well,
And that
that's
says-
either a bad transistor or it's bad soldering.
Yeah.
So, we'll find out here in just a minute. As soon as the soldering iron heats up, we will turn it off, of course.
And are you going to unplug it too?
Nah.
You don't really see a bad connection.
No, but solder can fool you. Yeah, this was dip soldered. You can see some of the joints didn't run very well.
Yeah.
I've been.
Well, I don't know. Those boards look really primitive compared to modern boards.
Yeah.
You know.
In 1972, this was high tech. Sometimes, if it's a bad solder job, a dip solder, when you heat it, it will sputter and smell like rotten eggs.
Mhm.
And that's because the solder wasn't hot enough, and the rosin didn't burn out of the solder when they soldered it.
It's a miracle that all the solders are working.
I've had boards that were not hot enough that worked for a number of years, and then over time the resin that remained under the solder would eat away the copper and leave the solder on top, so that there was nothing left underneath. You talk about hard to troubleshoot. We have some jacks at a company that shall remain nameless. It was an early two-sided board that had siphons in the board, little rivets,
Uh-huh.
to suck the solder up to the top of the board, to solder the top of the board.
Uh-huh.
You talk about 280 bad solder joints. I resoldered hundreds of those boards over the years. Got to where I knew every solder joint by name. Got me a little fan to blow the smoke away from my face so I didn't get sick. It smelled so awful. Okay, those joints didn't bubble. They didn't look bad.
Seem right on.
Yeah.
See if manipulating it fixes it.
Yeah.
Seems more stable.
That may have been it
Of course, you said it always worked when you turned it on.
for a split second. Well, at the first time, then it would come off. It would come on silent.
But it was acting like a bad solder joint because
Yeah.
it was.
Yeah, 40 years and a little oxide. It wouldn't take much. Now this will like to play for a little while until I'm satisfied, and I'll get the ESR meter out and I will check the capacitors to see what their AC resistance to signal is.
Right.
You can check them for capacity, you can check them for value,
Uh-huh.
and they can check out fine. But if they are drying out, they will start not passing high frequencies.
Uh-huh.
So they're being capacitors, but they're not being good capacitors. Your fidelity will go down if they're used as bypass capacitors. They're supposed to bypass high frequencies to ground, and they get where they don't pass high frequencies. You end up with whistling, feedback. In video, you get smearing in the picture.
Yeah.
So an ESR meter is extremely important for capacitor analysis. And the beauty of it is you can check most capacitors in circuit and be 99% confident that the capacitor is either good or bad.
You know, another thing is if you're fixing these switching power supplies that are everywhere now,
Yeah.
an ESR meter is just, you know, before you even do anything, just check all the caps.
Yeah, even if they're not bloated, check them.
Yeah. Well, sometimes they put glue on it and you think it's leaked and it's just the glue.
Well, yeah,
Yeah.
I can do a whole day on brown glue.
Yeah.
A lot of capacitors in circuit boards, they'll have 100 mic capacitors across the B plus line in 100 places.
Mm-hmm.
And in the case of that, and Panasonic's big video decks were bad about this, all the capacitors can be kind of bad, but because they're all in parallel, the ESR meter doesn't see them.
Mm-hmm.
You have to pull a few of them out of the circuit.
Yeah.
Test them out of the circuit. Go, okay, yeah, this capacitor is marginal, but all of them together
Are good.
looks good, but it doesn't mean that all of them together are passing the highest frequencies to ground, which they must do to maintain gain, linearity, minimize distortion. Yeah. But if you find some capacitors drying out, you can bet they're all drying out.
Yeah.
So, yeah. This is a good evening's work.
But it seems working.
So far, so good. So I will let that play for a bit.
And we'll call it fixed and I'll let everybody know.
We'll see tomorrow if it's still playing. If it is, I'll do some capacitor testing and send this puppy home.
Mm-hmm.
I fixed this for a customer for some other problem about a year ago, and he brought it back and said, "Let him quit." Well, fortunately for him, it's just a simple problem.
Yeah. Well, when they get older, you're going to have things.
That's right.
Okay. Well, thank you for for doing our show
Yeah,
tonight.
find me some other piece of equipment that's been running 40 years and is still working besides me.
Yeah. Well,
Yeah.
Pioneer, I like Pioneer.
Pioneer was good.
Yeah.
Pioneer was good.
What was your favorite one, Marantz or?
Marantz and Macintosh are still the Cadillacs, but Pioneer was a good, quality, dependable receiver.
Yeah. And here it is running 40 years later.
40 years later, it still works.
Mm-hmm.
All analog, no digital, and almost no integrated circuits. This one has these little primitive integrated circuits in the FMIF. Everything else is transistors, capacitors, and coils.
Yeah.
No.
Well, this was a
integrated circuits.
70s unit, is it?
Early 70s.
Yeah, so this is right out of the
70,
60s.
71, 2, 3.
Uh-huh.
I remember when these were new.
Well, this
Yeah.
is fascinating.
Metal output transistors.
Yeah.
Don't make those anymore. And it weighs a ton.
But still works.
Still works.
Well, I'm excited. Paul, thank you for fixing the stereo in front of us.
You're welcome.